welcome to the first ORCC Creative Cohort meeting. I'm really excited to sort of be able to read in the world on some of the conversations we've been having and the progress we've all been making. I'm really excited that all of us are in the same room, so to speak, together to sort of start this process collaboratively in earnest. I think it might make sense to start with just some basic intros. So I will start. My name is Chloe Brown. I handle communications and some community outreach for OpenAeros, which is the company that incubated the OpenRespirator and really developed the OpenRespirator manufacturing process. And this project we're all working on is an attempt to sort of road test and see what happens when we get creative people that prototyping process to make a mask that solves a problem of their own design and orientation. John, Wyatt, I know you've both individually been working on masks. Aaron is here to speak to the sort of commercial cohort side. So I'm wondering if maybe it makes sense for you to introduce yourself next, Aaron.
Sure. So I'm Aaron Collins, the president of OpenAeros, and I picked up the job of doing the commercialization side. So the objective of this was to take the sort of digital silicone concept that we generated, which was being able to rapidly create silicone and plastic co-molded parts. And so, you know, we worked with a couple of makers like Wyatt and John, but then there's the aspect of like, could we work with a commercial company to do something that kind of solves the need for them immediately? And so I'm working with Zini. They make a mask style that's like this, which is I'll try to keep it in focus here, which is a gasketed style mask with an internal frame. So this would be like what typically the frame looks like. And what we've been working on is developing a frame that is similar in terms of that, but it features silicone at the interface of the nose, but it could be other places too. It could be cheek. And really it's just driven by trying to enhance comfort. The plastic masks, this area here where it sits against your nose can become kind of rough and hard on your nasal bridge after long duration. So going to something that's a little bit more compliant at the nasal area can help with that. I think with the gasketing, the seal is pretty good to begin with. So it's just about driving wearer comfort. And that's my task, is partnering with them to make iterations and improvements to that across a variety of sizes that they offer.
Wyatt, would you like to go next?
Yeah. So this is about the sort of the product, right? Just okay.
Well, why don't you just introduce yourself initially?
Okay. So I'm Wyatt. My general background before this was in chemistry, and a little bit of making stuff on the side. Sort of the rest of it was covered in the short clip you guys posted. But in terms of masking, been masking for quite a long time, since the beginning of the pandemic. And generally just viewed as a sort of pro health decision, stuff like that. And then in terms of the project, what I'm working on is a way to make I guess you could say, the widely available bifold masks, the ear loop style masks, much better at sealing to the face. So the goal of what I'm working on is to first understand the dynamics of the bifold in that I've been working on developing a inner sort of brace that covers the shape of the bifold, and then using that prototype to develop an outer sealing mechanism and essentially create a brace that can bind to bifold masks and integrate with an elastomeric seal. So it's going to try to turn the commercially available bifolds of various types, we have to be precise because they're all a little bit different, into elastomeric-like masks. So the goal is to make the bifold masks, which typically have sealing problems, in terms of the sort of inconsistent nose wires and maybe the stiffness, into a product that can more better suit a wide variety of faces. So that's what I've been working on.
Awesome. Thanks, Wyatt. John, you want to take it away?
Yeah, hi, I'm John, and I'm an animation artist. That's my background. And also I have a lot of personal experience with certain environmental issues that could be from the air or temperature, lots of different things. So yeah, I was using elastomeric type industrial filter masks, throughout life for quite a few years before the pandemic, and then going in with that kind of knowledge to kind of like deal with all the little situations. So I've kind of used them in all these different scenarios, and I can relate to all the different problems. And yeah, trying to come up with cool solutions. And I think one of the things that crosses over with me is kind of the creative, like fashion, arty, costuming, the things that make life worth living, enjoyable. So how can we build some of that expression into it? And this just kind of what being inspired by Aaron, and kind of like all the testing that he's been putting out there, and then knowing about this OpenRespirator project where 3D printing is a little bit more accessible, easier, simplified, and then kind of trying to solve, I guess my project is trying to solve people's different faces. So to be able to either get a mold of their face or 3D scan their face to build something that they could print themselves, that then they could stylize themselves in the exact ways, their favorite character or something that they want to bring into existence and are willing to wear comfortably. And so, yeah, just working with Chloe, it's been great, just getting to know all the little ins and outs. And yeah, I'm excited.
I am also really excited. You have answered, all three of you, several of the questions I had planned to start with, including just sort of what it is that brings us all to the table around the questions of masking, and the questions of masking comfortably. I think it's really special that all three of these projects are working on some level with the concept of adaptability and accessibility, and making something that is both an answer to three very specific questions and also adaptable to virtually any face. And I think that that's part of what makes the OpenRespirator project so exciting to me. Maybe what makes sense, since we've all sort of done some basics, is to talk a little bit about where each of us are in terms of the design. Sort of, we've moved into this idea of like what it is that we're trying to do. Let's talk about what it is that you've done. Are any of you set to screen share? Is that something you would like to do, or do you want to just sort of talk through things? I just need to enable the sharing.
I can do that for some of it.
Okay.
Sure.
Yeah, totally up to you, Wyatt. However you want to roll this out.
Okay. Well, first, I mean, I can talk about my process, and we can look at some of the files that I've been working with.
Yeah, walk us through your problem-solving process.
So this one is kind of a challenging one, at least it was initially for me, because when you're making a 3D printable thing that needs to go with an already made product, you need to have as close to the exact dimensions of the product as possible in order for it to conform to that product. So what I've done is I've implemented one method for that, and then I've also done some hand modeling. Those methods in tandem to give me an idea of where to start with this. So I'll give a walk through the method that used the photos. I took photos of a bifold mask bent in sort of a circular shape that would be a little bit more circular than what you would put on your face when you wear it, like as a one that goes below the chin, because I wanted to have a gasket that sits sort of above the chin, kind of like the Zimmy mask. And then I took photos of it on the side view of the same sort of fold to capture the side angle. And then using those, I used Blender, and I traced the shapes, and then I stitched them together to produce the 3D one using both dimensions at right angles. So that was to get the gasket shape, and that is what I've been working with. In terms of the hand modeling, I used a different kind of N95. It's a bifold, but it has a larger nose piece just as a test. And I sculpted around that with, I think it's polycaprolactone. It wasn't polyethylene. The stuff you can buy on Amazon. And I made the inner and outer rings to see how well the idea would work. And with that, I had good success in terms of it conforming to the product. So that was a useful thing for me to look at. And I can actually screen share some of that with you guys if you want.
That'd be
great. Let me just get that. Where's the button? Oh, here it is, share. Okay. Screen.
I think there's share on the bottom right.
Yeah. Just the document I work with. Here it is. So we'll look at the...
John, could you mute for a second? Yeah, thanks.
Revision. So this was just the idea I was working with. These guys are can you guys see this okay?
Yep.
Yep.
These guys are the images of the bifold, like this one and this one, as you can see. And then I started tracing it sort of roughly to capture the shape. And then I did the same by extending it and capping it off to get the other one, just having them at right angles. And then putting them together, it looks like this. This is the one I did by hand. So as you can see, like, I literally took the polyethylene and sculpted it around the internal of the frame. And especially in this image, you can see that it conforms quite well. And the idea of having one on the outside, one on the inside, it seems feasible. There's other ideas, but this is the one I'm working with right now. And then this is like the outer piece. I mean, these were literally built while it was hot around the thing, trying to avoid fusing because they're very similar materials. And so from there, the idea I came up with was you have the inner piece with the inner frame, and then you have an outer one that sort of has a zip tie like binding around it to secure to the mask. And then these are some of the rendered components from the phase I'm currently working on. As you can see, they line up fairly well with the mask. These aren't perfect. Mostly what I'm taking from this phase is the internal structure, not these exact models. And then I started working on the gasket idea. It should be here, which is this. This is based on the actual shape, and the goal of a gasket like this would be that it friction fits to the two inner and outer layers. So basically it'll be a little bit thinner than them, and it can bind around, or it can be secured by some kind of locking mechanism. I haven't quite figured that out yet, but that's the idea, is that the gasket would friction fit, and as you press it to your face, the inner frame would push outward and secure the mechanism. So altogether, with this with these images, it was fairly doable to get a well-conforming shape with these models. So this is what I have so far. I hope to refine them by taking the inside of that shape and using it to actually produce the correct sealing mechanism, which should be a sloped inward mechanism, not necessarily one that would just cut out of the entire shape. And I'm going to proceed with that. So this is what I've been working on so far. I'm just going to stop sharing.
Cool.
Wyatt and I had a funny interaction about the gasket shape a couple weeks ago, where you had referred to it as heart-shaped before I had seen the images.
Yes.
And I, as a communications-minded person, was so excited about this idea of a deeply friendly, inherently branded piece. And I really see it sort of coming through there.
It's heart-shaped.
Absolutely. It's cool to see your process and progress on this. Maybe it makes sense now, since you sort of walked us through where you're at, to take a minute and see if John or Aaron have any sort of thoughts from watching to add, or questions or brainstorming to do.
Yeah, certainly. You can open that up.
No, I mean, I think it's the right approach. I think from one perspective, it's really kind of just proving the concept. So even if you didn't make it fit for every bifold that exists in the world, and made it just work for one bifold, right? Like I think that's a direction forward. And then, depending on the design, you could scale it to be whatever size bifold you have, so you could figure out what common brands are. So I think I would recommend not trying to get too stuck in trying to make it fit every bifold, because I think what's going to happen is you'll spend a lot of time thinking about that without tackling the other aspects of the design.
Yeah, I agree.
And so I would think like to me, the big challenge is like, how do you secure the silicone interface, which we're trying to make this kind of elastomeric seal, to that? I think that to me is the $1 million question in that design.
Yeah, I agree.
And so I think my recommendation would be just pick one bifold that you really like, right? The mask that you really like, or use whatever reason you might like it, breathability or comfort or availability. And just craft it around that. And then I think other people can be able to scale it on their own, or you can make your own versions that scale it for different size masks.
Yeah, I was thinking about doing that. The one I used for this was like literally one I had, but the brands I was thinking of using were like the readily available ones on like Amazon that are N95 certified, like BNX, stuff like that. Those black ones, I think, is the one I want to use for.
Yeah, that would be good. I think any sort of those more trusted words. I'd be a little careful. If you know me personally, I'm a little careful about the brands on Amazon.
Right. I didn't mean those brands. Yeah, I meant some are sold on Amazon, but they're not the knockoffs.
Yeah, exactly. Perfect. Yeah. Because there's some questionable brands on there.
Yeah. There's bad blood, understandably.
What's your thoughts, John?
Yeah, so I guess it's awesome, like, to think of a way to convert a non-elastomeric into an elastomeric. And if there's a variance in the bifolds, I guess that would become some kind of like a database. Like you'd have to sort of train each person who's kind of made it this far into this level of interest in respirators, masks, that they would scan their own and then test it. And then once that's tested, that first one, that will be paired sort of with that particular model, maybe in a file, until the next person comes and figures out a better one, of that model. So each model kind of gets, it'll be almost like Thingiverse or Thangs, where, because I remember back when I was trying to figure out how to plug the exhale valves for 3M P100s, it was per model. Like you'd have to find the one that's exactly your model, but they ended up existing after a while, So I think that's kind of how I would envision it, like kind of jumping on what Aaron said, is like you focus on the one that it works for you, and then that becomes a proof of concept for the next person who would want to emulate that, I think. Yeah.
I see that. I'd also like to add something like the silicone gasket I'm working on. The one I showed isn't the exact one I have now. I sort of added a web to the inside, like kind of like what most of them have to make it more secure, because just that ridge isn't enough. But I was thinking that those could be modified. Like, if someone's working on making them better, we could have one for a high nose bridge, one for a low nose bridge, and we could integrate that with the back end of it, because like the front of the elastomeric can be modified. So I was thinking that could be an interesting, maybe collaborative thing.
Wyatt, I think something really exciting about this idea of the silicone interface is the fact that the silicone becomes what is making contact with your face,
right?
As opposed to a disposable mask that you use a few times and breathe food breath into and, spread the same skin germs over and over again. Or for people, there's several people who have skin that gets very reactive to mask components and melt blown. And I think that there's like a universalizing through line here that is really cool. I also, the idea of it being cleanable, I end up wearing masks that have yesterday's makeup in them more often than not. And the idea that I could just wipe it down, take it off and put it on another mask or the same one is really exciting to me. It makes a ton of sense. Is there anything that you have been noodling on, Wyatt, that you would like to just sort of bring to the floor while everybody's here and do a little problem solving on? Or is there nothing sort of pressing right now?
Oh, well, I think what Aaron brought up about the silicone is an interesting question that I can't necessarily even really answer as well until it's, I have it, and I can see how it feels. I was thinking about friction sealing and sort of modifying the density of the silicone, because I've seen other masks do this, where if it's a thick rubber and the slip is thin enough, it can grab onto the plastic. And if you're pushing that against your face, is the question really is that enough, or does there have to be some other securing mechanism that links the two parts together? Because I think as long as the 3D printed materials are smooth enough, or if they're made with a mold that comes from the 3D printed part, I think that can be taken care of. But I think that's the question I need to figure out is how to make the silicone work.
I'm getting blasted. I had to unmute myself there. The sun is shining through the office here. Yeah, I mean, I think when you think about that design, there's kind of a lot of different. I think getting the interface of the disposable respirator to seal against the silicone is a challenge, but I think there's a lot of opportunity too, right? Because like in the design that you showed, you were using a kind of what appeared to be like a clamp mechanism with an outer plastic layer that's going to squish in there.
Yeah,
there's a lot of flexibility that you have, because you can also have, the nice thing about co-molding is that you can also have a little bit of plastic on the inside of the silicone side, so that you get a little taper seal, so that there's like a solid mechanical force that's sealing it, and then that transfers out to the silicone gasket seal.
That's a good idea. I like that.
One of the challenges that, or at least one of the limitations of this approach that we have, is that you kind of do have to work with a uniform silicone density, because when you cast it, basically when you eject the silicone into the mold, it's kind of it's going to go wherever you have it. It doesn't mean you couldn't design a system in which you had different injection paths, but it gets hard for the silicone to commingle without having some barrier between them. So like in theory, everything's possible in the world, but it would be a little bit more mechanically challenging. So I think I would constrain it to just be a single silicone density or durometer. But I think you got the advantage that you can have plastic on both sides. So the plastic can act as sort of what you were talking about, right? Like having something that's a little stiffer, and you can embed the plastic in there. That would effectively give it a much more stiffer feel to it, in the same way that you would have with a higher durometer. You could even embed PCL too, right? Like where it's heat moldable. I would recommend trying to avoid the PCL in the 3D printing process until you really understand how the thing works. Then you can kind of tweak it to add the heat moldable inserts. But like in theory, you could do that later on too, because the PCL is nice because it's flexible. It has a lot of flex. Like the PCL, when it's thin, it's very, very flexible, can distort pretty easily, which is useful if you're just trying to add a little bit of compliance without making it too stiff.
I mean, that makes me think of another idea. Thank you for that, first of all. The second idea is like, if you had sort of slits in the silicone itself, you could embed those around the nasal parts and the chin to give even more support, like it almost like an implant. I was thinking that could be kind of interesting.
That was one of the original concepts for the OpenRespirator design, was to do some stuff like that. If you look at the CAD model, there is like a hidden nose wire inside of there and one along the chin, which was that kind of concept. It ends up kind of being difficult to implement in real life. Because, well, what you end up doing is you just run out of time. You never have enough time to make the actual fundamental mask itself good enough that where then you get to the heat moldable inserts being there. That's what happened to us. We just ran out of time. And by the time we had figured out the pleating and making this and documenting it and releasing it, the heat moldable side of it was like, well, it's interesting we can do it, but you need to really have a good understanding of the core design that you have, where then you can transition to that. So again, I would recommend avoiding the heat moldable stuff until you're like, or enable something that you couldn't do otherwise. That would be the way to look at it.
Yeah, I think with a big mask like that, like the one you guys designed, I mean, once you get it large enough, there's also the question of, is it necessary? I mean, just because, once you get a big enough elastomeric, it has all those nice features, at least it's like diminishing returns, right? I think the only time it really matters is in like a quarter mask or something like that, where there's that, it needs to fit, right? Stuff like that.
Agreed.
Sorry, I'm waiting for some sound in the office to die down. John, while I wait for that, could you walk us through where you're at with your process and the problem solving you've done so far?
Yeah, sure. Oops. Someone's trying to call me. Sorry about that. Share screen. Okay, can you see that? Yeah. Yeah, so my process is pretty meandering. I'm often drawing, sketching, trying to sketch for a look, but also like understanding the parts. And so I'm often drawing on paper or in another software that I'm more comfortable with. I'm starting to learn Blender now. I have a little bit, of experience here and there from trying to 3D print stuff, starting to draw in Blender a little bit. But basically, and I always get a little confused with the navigation because I'm used to some other stuff. But so if I click off the visibility of some of these, so this is like my face scan. This is, and I have it over there, like the actual plaster cast model. But basically, I put Vaseline on and put some plaster of Paris on my face, let it harden. So that would be the negative. And then when that was done, I filled it with some paper mache, kind of, and then I had a positive. And that way I could take it to a lab to get it 3D scanned, which is as a replacement for just me having my face scanned, but it wouldn't be like necessarily super safe for me to do that just at a random 3D scanning lab. So I just brought my face mold to get it scanned. So that would be my solution for someone who isn't, the air is not necessarily like clean or whatever. So, and that's an activity that I feel like kids have done in schools and could easily do. So it's kind of like mixing in some art into it, which is always fun too. So now that it's in my program, which, go around and look at it. Basically, I started modeling. Wait, let's see. Let's see if I have. Yeah, I just tried to create something based off of the sketches that the team was interested in, because I did a whole bunch of different sketches to solve different problems. I have ideas for straws. I have ideas for transparency. But I felt that you guys wanted something like, finally, something like kid friendly, something that a younger audience, or maybe creative, like going to the conventions, would be excited about, So, and then, I often, I don't know, maybe I could show you, like, I'm sculpting stuff too, like, so this is like stuff that I'm sculpting for fun out of like non-recyclable type of materials, so I have these ideas for respirators that would have these kinds of themes, that are more like, pop culture references. That's kind of what cosplay sort of is. It's not your character, but you're just trying to emulate that character to have some community over this, love of a character. So I think that this could fit nicely in that whole culture where you're just adding testable filtration to the stuff you're already trying to do, is like make a costume. And so basically I'm just trying to get a handle on all the different like proper ways to model something. So I've got some help too, like friends who are online that are really into teaching me Blender. Like I'm working with them. So, and then I'm learning grease pencil. Grease pencil is a way to draw in 3D. So I'm just that's kind of what I had up here. I was just sort of drawing, like, kind of before I did some of the geometry, I was sort of sketching it like this, just because I'm more comfortable with the drawing side. So what I have to do is, without the face and without this grease pencil, I got to get in and figure out the inside, because I haven't quite figured out the little sort of gasket interior. But that's my next step. But I wanted to, get some feedback on this. And basically, these filters here, they're sort of meant to be like the cartoon cheeks, like it's supposed to, it's not fully finished, but it's like, the idea is a lot of these cartoon faces kind of have like a cheekiness, like a shape to their faces. And maybe those filters could take up that visual design. And then the front panel is meant to, either I go and I say, this is a respirator of this character, or I leave that panel sort of open for the person to paint their own mouth or face or whatever they want, and then that could be paintable and it could be updatable, like, so you could have this component that you're able to customize as you like. And then that's kind of, so I'm trying to figure out if I'm going to have it like completely flat or have some of this sort of like cartoony nose mouth shape. So I'm just testing it out. And then with the ears, I'm kind of planning that to be part of the head strap. So a lot of the elastomerics, they have particular design of a head strap. There's like an oval thing at the back, and I've been looking up some tutorials actually for ears. A lot of times they're made from cloth, so it could potentially be something where you could make that. It's lighter, but then it could be fastened to the structure of the respirator, or it could be 3D printed as well. So I'm just trying to figure out materials and weight, because you wouldn't want too much weight up there. So I did look at a Pikachu ear tutorial. It's really funny looking up. It's really funny when you're looking up YouTube stuff to find something that's relevant to you, but it's buried in something else that's completely something else, and you're watching it. It's just entertaining, I guess, for me. But that's kind of where I'm at.
I think it's really exciting to be thinking about how to make something not just like friendly to the wearer, but friendly from the wearer. And the idea of, we could call this a Pikachu. We could call this, for the purposes of the project, a really adorable rabbit direction. But to have something that's so...
Sorry, Pico 100, like P100.
Yeah.
No. Yeah, it doesn't have to be branded anything.
Right.
It's just kind of like a jumping off.
Well, and I think it makes the mask like a feature, not a bug, of what you're trying to communicate, either with a costume or if you're getting dressed for an event that isn't themed but is like a dress-up situation. It makes it a part of opting in a way that I think communicates something really important. I also think it's really cute. Like, I'd wear it. I'd wear that to the grocery store. Is it wild to wear a rabbit mask to the grocery store? I don't know that it's more wild than wearing a mask at this point. And I think what you've accomplished in terms of moving from your medium, which is so 2D in so many ways, except for your sculpting practice, into this is really exciting so far. Wyatt and Aaron, I am curious what your sort of initial reactions are in terms of questions and next steps you might sort of be picturing.
I think the cosplay side of this is really interesting to me. I think the idea about using not just making masks when you think of traditionally of like a cosplay, like partial mask or something like that was covering your face, but to now integrate sort of respiratory protection into it is like an interesting aspect. And really, I think really pushes the boundaries of what kind of the process can do. So I'm excited to see what this looks like. I think creating something that's really kind of kid friendly, or at least kid-like, even if it's for adults, is a fun aspect that I think really challenges what an elastomeric respirator needs to be. Right? I think we oftentimes end up with these very industrial designs because, like, I think no other reason than like people are just like, yeah, whatever, who cares? We'll just make it work, and like they don't really give thoughtfulness to that. They don't, they maybe hire an industrial designer and say like, oh, kind of make it look like this, make it look, more facet or less facet, but they don't really think about the fundamentals of what they're trying to show. So I think it's really exciting. I think some of the challenges that you might run into, John, is I think one is looking at other quarter or half mask respirators, right, where you can kind of take some of the seal design from that might help a lot on the inside. I think getting the filters and integration, all that will be in the shape that you have. Not impossible, but like just be cognizant of like if you're going to use a pleated filter design like that we had on our respirator, that can not impossible to do, but just be cautious of like how you design the filters and how they click in or how they're going to interface into the rest of it. But I think it's really cool. I think also like there can be a lot of like co-molding, right? You use plastic for some of this, like the mouse or like some of the whiskers or sort of like the more stylistic animal shapes could also be made from plastic. And so I think there's a lot of opportunity. I think it's going to be really exciting to see how this project continues on and what you end up with.
I love the idea that this is a product that makes life not just safer, but like makes life more of what life is about at the same time.
Right.
And I love also how incredibly customizable this is, not just in terms of shape, not just in terms of animal, right? It's not just like, you know, if once this is published and somebody's got a mom with a great 3D background who can turn this into a mouse instead, like that's amazing. But also the idea of adding fur to the ears or painting it yourself or choosing the print color, all of that being so individualized really, I think, affirms the idea that like as something opted into as part of a health and safety practice, this can be something that is like, it's not de-individualizing. It's in fact incredibly personal. And I think that's so smart. It's really exciting. Wyatt, do you have any thoughts to share?
Yeah. So first of all, I think it's a really cool concept. I like the grease pencil sketch a lot. I think that's just kind of cool from an artistic standpoint. I think one thing that might be worth considering is making the filter attachment points compatible with 3M and other products like that. So people have the option to use existing filters in addition to ones you might design, just because sometimes those are more available, even though they might not capture the look exactly how it should be with something like this. They might be one of the more convenient options. I also think you could maybe work on designing cases for those filters that are more integrated with the shape if you wanted to.
I think actually that was something that was in some of John's early sketches, was filter cases that had those designs. I remember a star case actually.
Yeah, so I had two questions because Aaron, you mentioned about the pleated filters that is part of the OpenRespirator. So that I'm trying to go with that in mind. So does that mean, because you're saying, because I'm just modeling the shapes right now, but I guess it means that the mask has to be a one piece where the pleated plug in, and maybe my model right now makes it look like it's separate pieces. But I had it in mind to follow sort of the OpenRespirator, how it functions, where you print your own filters and you pleat them yourself and then they plug in. So how would I make this more compatible? Because you said it's not impossible, but what are the problems in even just the shape, how I've done it? I just wanted that feedback. And then to Wyatt, yeah, like I totally love the 3M filters. So in the future, when we complete this project and I'll be able to print my own stuff, I'm for sure going to have mods and all that. I'm already in that right now, painting those and doing whatever. So yeah, but this one is really so that if you had to, you could print everything with the filtration from scratch. That's kind of the goal, is in a bind. But yeah, to Aaron, just in the details.
Yeah,
just curious.
Yeah, no, I think that's a good question. So I think there are kind of two things. One is I wouldn't be afraid of using a bayonet style connection like you do see with 3M and other ones. That's fine. You can do that too. I think it's a little hard with 3D printing to get the seal surface really well, but it isn't impossible. You can also do it there are many different ways. I think when we think about what we did for the OpenRespirator design, we had that the outer portion, I should have grabbed one with me. I didn't grab one in the office here with me. The outer portion of that design is silicone. So it inserted into a piece of plastic that was securing the seal. And so it very much is based on the GVS 1000, the Eclipse GVS 1000 design. If you ever have seen those filters, or if you want to buy some, you'll see that they're very similar. We kind of borrowed heavily from their approach of pleating and then potting in silicone. So the GVS 1000 filters are very similar, and that's what we did. In fact, if it was me in your shoes, I would probably just start there. I would kind of buy some GVS 1000 filters. The Eclipse filters are like the silicone versions, and then just kind of integrate them in there. And then once you figure out, okay, I want them a little bit different shape, then you can go to the pleating section. But then that will at least give you something to start with without having to do all parts of the project. It is what we did. We started with the GVS 1000 Eclipse filters in that design. And then you could also think about the filters that you have now. That those could be plastic covers too that could clip in or still be something that stands out like a cheek, and it could be a plastic cover for the filter. That's probably in some ways advantageous for a couple of things from an aesthetic standpoint. The pleating, I mean, it kind of is a very like, I don't know, that structured pattern of a pleat can somewhat be, I don't know, it doesn't feel organic necessarily. Whereas with a cover that you can you can kind of both cover that so you're not seeing that and create a more organic shape, but also you prevent impact damage. So like we were thinking about a kid's version, like that becomes an issue because they're going to smash it into stuff. So having like a small thin plastic cover over it could help. And so those are all, I think, easy ways to get around it, to do it. But I think the biggest takeaway is take a look at those GVS 1000 Eclipse filters, the P100 versions. They'll get you a pretty good start. I think if you lay them over ours, they're like very similar. I think we end up borrowing heavily from that design aesthetic.
Yeah, I just like.
Yeah, as a true hacker would. Oh, sorry. Go ahead.
Oh, sorry. Yeah, one last thing on that. You might also want to consider the Trend Air Stealth. I'm sure you're familiar with this. Those little filters are also, I think, great because they're much smaller than the GVS, and they have like the same filtration capacity, so they might work better with the design you have, just as a potential option.
Yeah, good call. Yeah, that's another. Yeah, the Trend Stealth would also be another one. So that's where I would start. I would start finding something that's kind of similar in the vein of what you're trying to do, and not have to go straight all the way to making your own potted filters, because that took us a little. I mean, you'll have a head start in terms of the mechanical design of like how you do it, but it's still a tedious process. I will not. It's my least favorite part of having to make that mask.
I think it might be a good opportunity for us to transition to sort of the commercial cohort. Aaron, can you walk us through where you and Zini are?
Yeah, so I don't I have the CAD model up on my computer at the moment because I was unfortunately in another activity right before this. But so what we're working on right now is basically so Zini actually has a few different sizes of masks. So if you're not familiar with the Zini products, they are this gasketed mask, and there's a few different designs out there, but they come in different sizes. So they have like a small, medium, a large, and an extra large. Oh, look at that! Someone's bringing me my equipment. Watch as they suddenly appear in frame in another camera. It's like there's technology, or they're actually. So these are the actual frames that we had made. And so what we're doing is just adapting, working with Zini. They took their design and then we adapted the exact one-to-one design and then started adding silicone. Now, some of the challenges that we have in this design is that if you take the one-to-one design and try to put in the Zini mask, that the silicone's a little soft. And it also is a little thicker. And so what you have is that there's not enough pocket space inside this inner frame mask to fit it all into here. So you have to scale these a little bit to accommodate for the change that we made here. And so that's kind of the first thing is, but so far what we found is, and we're working with Zini directly as we kind of ramp them up. So they're doing the CAD design. They send the CAD design, we print it, we give feedback, and then mail it to them. And then they're looking at it. So it's shorting up a little bit. I eventually want them to print this stuff, and if they watch this, hopefully they'll be convinced it's a great idea to be able to just design it, print it, test it all in one day. But we've got this down to, we get the CAD model from them and we can turn around a design in the next day. So we start at like 3 p.m. on the afternoon. By 3 p.m. the next day, we have a fully functional piece like this here. So we'll be working with them on a large and extra large design. We're going to focus on trying to solve one specific issue. So we kind of thought of like, what is the biggest complaint about this? Well, this particular extra large mask, it fits okay for my nose, but if you have a taller nose bridge, this mask does not fit very well. So you end up with these gaps right here, and you end up with pressure points where it's too narrow in there. And so our first thought was like, if you have a tall nose bridge, these kind of masks haven't worked well. And could we fix that problem? Because I think that the gasketed style has some big advantages, and that people have been kind of hung out with not being able to use these. Or if you go onto some of the mask discords, people are modifying it by trimming it, by cutting it, by adding foam, and so you end up with this like kind of trying to make it work by removing material or making it more compliant. So we're just going to take that and make it compliant. The big challenge that we have right now is, like I said, the gasket, the fitting this into the mask frame is into the pocket is a little challenging. So we need to scale it down. But just figuring out the geometry of how thick the silicone needs to be, both because to be compliant to your face, which is nice, but also when you install it into the mask, that it doesn't just like get all distorted, like it pulls the silicone. I'll try to do it on camera here, but it's always a challenge to do. Never do anything live on camera. That's always the rule of thumb here. Let's see if I can get it in there. but it is a challenge to install it. I'll do it. I'll show you what I'm struggling with, because I think that's a real problem with this design. So we have to kind of adapt the design to figure out, like, and the silicone makes it a little harder to install too, because it grabs onto the material. And so working this on, and it is a little easier not to do it up at your eye height, but I want to make sure everyone sees it. Okay, there we go. So it's getting in there. All right. It's almost in there. So this is the challenge with this design. All right, I'm going to move it down out of your view so that I can finish getting it in there. Uh-oh. I had it upside down. Who designed this thing? Me, apparently. All right, we might not be able to get to see this live because it's too hard to do it. I'm trying to do it live in Rush. But it is a little bit difficult to install this into the frame. It's not as difficult as it's showing on camera. But when you put it into the material, what I was happening is when you pull this over, what was happening, the tension of this was pulling the silicone back. And so that would mean that it like wasn't really providing the gasket interface you want. So balancing the structural portion of plastic, the compliance of the silicone, and how much silicone you need to get the shape that you want. But what I'm most excited about in this design is being able to rapidly change the profile around this nose area and being able to adjust that. Luckily, we have someone in an office that has a tall nose bridge and has been our test subject for this. And really what we're trying to do is design the Zini mask for them, because the Zini masks haven't worked well for them in the past, where they hit right on this portion of the nose, and because it's hard plastic, right on that portion of the nose for that individual, it's just like not comfortable. So they're our test case. Like, hey, can we make the Zini mask work with people who have traditionally not worked with it? So we'll be doing a large and extra large, making it compliant. And then our vision is it's a little different than the non-commercial cohort, where we have a little heads up because we kind of had a head start on this, and we kind of have a huge advantage that we've spent the last year and a half developing this process. So we get a little leg up in terms of how long it takes us to do it, is to make a bunch of samples and send them out to people and see how they think about it. So once we kind of establish our test case in the office and saying like, okay, yeah, this kind of feels much better than the other one, let's take that and replicate it and find other people in the mask space who've been trying the Zini mask and had problems, and see if, one, it solves the comfort issue, and does it improve? Hopefully you can keep the same fit or improve the fit. And so that's what we'll be doing over the next couple months. And so we're waiting right now just on Zini to get us another design back. They were on, there's a Chinese vacation that was happening between October 1st to 8th. So when they're back, they'll get us a new design. We'll print it. We'll test it with John. We'll mail it to them and get feedback. And then if we're kind of happy with it, we'll replicate it a few times and send it out. So it'll be exciting to see what we can do with them.
John and Wyatt, do you have any reactions, questions, etc.?
So yeah, with the Zimi, which I generally love as a product, by the way, I agree with what you're doing in terms of making it, the nose piece, I think on a lot of them is not, like often for high nose versions, it's not like you can't get your nose in as far as you would need to without cutting it. Because like I wear them and I cut them and they perform really well in terms of fit testing, but they're not, as great for a lot of face shapes. So I think this is a good product, especially for people who I also know they don't like the pressure on their nose. Like for me, it's not a huge issue, but I know a lot of people who they really do not like that. So this is definitely a valid concern with that mask. So I think it's a good product there, just to work with.
You can also criticize me too. It's okay.
No, I don't think I have any. Yeah, I think so far it looks, the silicone integration behind the what's it called? The what's it called, airtight fabric, I think is also a great thing, because I think putting fabric in front of silicone was something I want to see tried for a long time, and so I think that's solid. Then I agree with you about getting the frames in. That's the general challenge with Zimi. If you want to use the ones that are not pre-installed, it does take some time, and I always worry about damaging it. So I think that in general needs to be improved, but I'm not sure how to do that exactly.
Yeah, I think we'll be playing with that a bit to see, and I think some of it might be that if you get to a little bit more elastomeric material, you might be able to make the frame a little smaller, right? So you're not trying to get the frame really tight using the plastic to hold it and secure, and see if we can take advantage of a little bit of the silicone to try to help doing it. Right now, the biggest problem is when installing is that the silicone gets caught, the fabric kind of catches the silicone, like it doesn't drag like it does on the smooth plastic. So as I'm trying to put this in, it's like you kind of have to like push it in there. And so that's probably to me one of the biggest annoyances with this design. I'm not sure yet how we'll fix it. but I think there are some design options. Like this is the large frame being installed into the medium, or sorry, the large frame into the extra large, the large frame into the extra large mask filter itself, and that goes in a lot easier, and you can wear it. It's a little offset here. You can see that I accidentally put it in a little crooked, but it does fit a little bit easier. So I think that the answer is like, can you design it so that it's easier to install by shipping it and using the compliance of the frame to take care of the rest of it? Let me keep working.
John, it looked like you had some feedback.
Just more like on a personal anecdote situation, like a family friend, their partner, it has a very hard time finding any kind of mask because they're very large, facial features and head size as well. So even most large and extra large, there's something like it doesn't quite cover enough, or it cuts in. So I'm just curious if there is a limit to this mod where, like you're talking about the nose size, but is there a point where they just need a bigger one in combination with these mods, or lengthening straps? Because there's not just the facial features, but just the overall size that some people who, I think there's also these roles we play, if you're a really big guy, that you're not supposed to be, taking precautions or something, and it's like people questioning, so it's like doubly hard for them because the sizes just aren't there. And then there's a certain point where you're putting in too much effort. It looks socially, you're unable to get protection for all these different reasons. So I was just curious if it's addressing some of these size issues that I was just talking about.
Yeah, to some level. I think one of the challenges with this, and this is why I like bifold a little bit more, but in particular with this gasket install, and I got the frame installed, so now you can see it inside of there. This is what it looks like when you wear it. So it basically fits just like the Zini, but now there's a lot more compliance in the nose and you don't have the hard plastic. But the challenge with the Zini mask with the gasket is that to make the different molds is very expensive because you have to not only pleat down the middle or seam the middle, but you also have to add this gasket. So it makes the mold cost quite a bit more expensive to address different sizes. It can help a little bit with making the mold a little cheaper to do these prototypes of the inner frame. But it really, I think the goal of us is to try to just adapt an existing design, but I think it does not address the issue around a wide range of face sizes. I do think the bifold style mask that like Wyatt is working on, I think holds more opportunity for manufacturers to make a wide range of sizes because the molding cost is much cheaper to do the bifold than other styles of masks. So that hopefully if you could get enough market interest, right? So like I think that's kind of the nature of this is like I don't think we're ever going to have one mask for everybody. I think what's going to happen is you're going to have like niche of masks, just like we do with shoes, right? Like there's people that have wider feet, so they always like these type of shoes, or people have different styles of feet, so they end up with different shoes and different shoe brands. But lowering the barrier of entry and cost associated with developing those, I think is really critical to enabling people that have access to like an extra large or an extra large, or right, because I think that's where it drives. And so I think overall the project can help with that, but I don't think we're going to get to it. Unfortunately, I wish we could, because I think that is a big issue, and really small and really big. I think the extremes of the distribution, like there's not enough market economy for people to go and target those people, because it's like there's not a lot of them, they're hard to find, and then like the sales volumes is small, but those people need protection too. So I think that's kind of the challenge with the disposable respirator market in general. I don't know if we'll get it, but it is a good point.
And anyways, if you're gonna send out some samples, I'll send one over and see.
No problem. You can order to you. I figured out how to correctly export them across to all countries.
And with that insidious little threat, I think maybe we should call it for today. Thank you all for being here and walking us through where you're going, where you've been, and what's exciting you. I will be posting this on YouTube and Discord, and my guess is that we'll have a couple more questions filter in over time that way. But I find this all really inspiring of a lot of hope, and I want to thank you all for your work on it. And I guess we'll see you soon.
Yeah. All right. Thanks, John.
Yeah,
Thanks,
take
Wyatt.
care, everybody.
Yeah, bye.
Have a great weekend.
Bye.
Bye.